The ML125 NIBP system performs non-invasive blood pressure measurements on mice and rats using specialized tail cuffs. The system provides a good estimate of actual systolic pressure, whereas diastolic pressure can be derived in lab chart, but is a less reliable measurement. The two main components of this system are the NIBP controller and a tail cuff for either mice or rats. This training video demonstrates the correct use of this equipment and includes a live demonstration of non-invasive blood pressure recording from a rat. Before performing blood pressure measurements, the subject animal must be introduced into an appropriately sized restrainer. In this instance, the rat weighs 210 grams, and we are using the rodent restrainer for rats weighing 180 to 320 grams. Once the rat has been introduced into the restrainer, the length of the restrainer can be adjusted to comfortably restrain the animal. A towel is placed over the restrainer to help calm the animal, and a lamp is placed close by to keep the animal warm. The tail cuff is slid over the subject's tail along the tail cuff holder until it rests closely to the tail end of the restrainer. The tail is also placed securely within the pulse transducer. Once secured, ensure that the pulse transducer is not in contact with the tail cuff, as vibrations from the cuff may affect the pulse signal. It is recommended that the subject is allowed to acclimatize to its new surroundings for at least 30 minutes prior to acquiring any data. Connect the I2C output of the Power Lab to the I2C input of the NIBP controller. With BNC cables, connect the pulse signal output on the back of the NIBP controller to one of the analog inputs on the front of the Power Lab, and connect the pressure signal output on the back of the NIBP controller to another of the analog inputs on the Power Lab. Connect the pulse transducer to the pulse input connector on the front of the NIBP controller, and connect the pressure cuff to the cuff connection. Select the appropriate pulse range on the front of the NIBP controller. The maximum cuff inflation pressure can also be selected on the rear panel. In lab chart, set up two channels, one for the pulse signal and the other for pressure. You may also like to use cyclic measurements in the third channel to calculate heart rate from the pulse signal. The pulse channel range should be set to 50 millivolts and the pressure channel range should be set to 1 volt. Units conversion should be applied to give 0 volts equal to 0 millimeters of mercury and 1 volt equal to 300 millimeters of mercury. Push the start-stop button on the front of the NIBP controller to begin a measurement cycle. The pump should start and the tail cuff should inflate. Observe that the pressure waveform climbs up to the preset maximum cuff pressure. The pulse signal should start to decrease as the cuff starts to occlude the blood flow. When the maximum cuff pressure is reached, the pump will stop and the pressure will begin to drop slowly. As the pressure drops, the pulse signal will start to increase again.